So climate systems are really complicated. If you're not confused already, that's just because it's haven't had a lot of details so far. If you go get a PhD in this, you'll see that there's a whole bunch of little factors. You know, it's a complicated planet. It's a big old planet. We're just figuring it out. And so at number 23, your book gave you some of the positive and negative feedbacks, and you have to know those, but I want to add to that list some things that were not in your book. I mean, I think, yeah, I'm definitely adding to that list. In case you forget, positive feedback are cycles whose output makes more of the cycle. We say that's self-perpetuating. And negative feedback is a cycle where the output prevents more of that system. So a self-regulating cycle, right? Like positive feedback would be that my wife says I'm gaining weight and I feel bad about myself, so I ugly cry and eat a bunch of ice cream to soothe myself, and that makes me gain more weight. So my wife says, hey, you're really putting it on, and I go ugly cry some more and I eat some more ice cream, right? So I put on more weight. And this is the ugly cry, self-soothing ice cream positive feedback loop that explains my ongoing body weight spiral. There's a separate possibility, right? Some people don't do that thing with the ugly crying and the ice cream. I got a buddy who every time his wife says something that's not flattering, puts on his running shorts, runs like 10 to 15 miles, then does push-ups for a month, sit-ups for a month. And you know, his wife likes him better when he works out. So that's self-regulating, negative feedback. And people have been looking for a long, long time, you know, what are the negative feedbacks? How does our climate regulate itself? Because holy crap, wouldn't it be nice if a heating planet made an output that lowers heating? Those things do exist. That's encouraging. Here's the negative feedbacks. These are what we call negative forcers, right? So these are factors that lower how much of our radiant heat is forced back to the earth, right? They let the heat go away. Open the window, make the greenhouse cooler. One thing we know is that on a warming planet, you tend to get more photosynthesis. Plants and algae grow faster. And that means they're going to soak up CO2 more, right? You have more carbon living in biomass, which would lower warming. How nice is that? The planet gets too much CO2 and you just fertilize the plants that use up the CO2. Slam dunk. You know, I told you that our planet is getting more swampy. Well, it kind of matters where the clouds are. So if they're really high, you know, it's cold up there, so that water vapor will make little fine ice crystals, and ice is shiny. High albedo. So there's another one. On a warming planet, you'll get more high clouds, and this is a fine detail. Make sure you write that down. The high clouds have more ice. So high clouds will lower warming because they're shinier, they're icier. And you know, all that extra swampiness means there's more rain falling, but that also means there's more snow falling. So maybe we'll cover up some of those dark rocks with some nice white snowpack, and that would make the planet shinier. And again, more albedo would lower warming. All of these are known realities about climate. They're all included in models. But the positive feedbacks are way stronger. On a warming planet, things happen which make us keep more warmth. And what we hoped would be like a pressure relief valve that the planet self-regulates, turns out the planet is self-destructive, like I am with the ice cream. Turns out that there are stronger positive forcers. Planet heats up, we put on a jacket. For example, rain on snow events. It's true that a warming planet will make more rain, but that's not necessarily going to fall as snow because the planet will be warmer. More snow days are now rain days. And maybe you know that when you put rain on snow, the snow melts. Skiers and snowboarders know this. Spring conditions are slushy. So because our planet is warming, instead of having snowfall 200 days in the Alps, you have snowfall 100 days, and you've added 100 days of rain falling on that snow, and that melts the snow. And that means that rocks poke through, and that lowers albedo. The Earth heats up more. Because on a warmer, swampier planet, you're going to get more rain on snow. So albedo goes down. The rocks are washed clean, and they are dark, so they absorb more heat. Absorb more light, and then radiate more heat. Excuse me. We measured. It was a mystery for about 20 years. Would that water vapor be tall and icy, or would it be low and steamy? And it turns out the majority of clouds are now hugging the Earth. They're not making extra high water vapor. They're making extra low water vapor. And down here, ice does not form. But water vapor is a greenhouse gas. Tropospheric water vapor. So that traps more heat. We're adding more water as low clouds. And that makes the planet even hotter because water is a greenhouse gas. Believe it or not, we can actually measure this. On a hotter planet, people with air conditioning use more air conditioning. It's a significant factor in increasing electricity production. Right now, the primary driver of power outages, of power shortages in the United States is people running the air conditioning on hot days. It's a really significant impact to our electricity usage. And of course, that electricity gives out more CO2, which causes more warming. It's a really gross idea that on a hotter planet, the people who can afford air conditioning are making it hotter for everybody else who can't afford air conditioning. Boom. And number 4, this is the biggie. The elephant in the room. The feedback that overwhelms all other feedbacks. You remember when we talked about energy and natural gas, I told you that methane, natural gas, that methane is the result of anaerobic decomposition. And if you have stuff decomposing while ice is forming, like bottom of the ocean where it's really cold, or like permafrost, the ground that's always frozen up north in the tundra with the extreme seasonality, you get into that long winter and all those plants start to rot, and then the ground freezes solid, you get what's called methane hydrate. It's not a bubble in ice. It is ice where between the matrix of ice molecules, you've got these little tiny methane molecules. It's not a bubble. It's just trapped in ice. This is ice that includes something else. There's a lot of methane hydrate. If you're ready to freak out, you can take all the radiative forcing that humans have caused. There's enough methane hydrate on Earth to do 10 times all the warming that we have done. And as the planet heats up, permafrost melts and that releases methane, which makes the planet heat up because methane's a greenhouse gas. So this is the runaway train. This is the part where global warming, even without us, makes continued, ongoing, increased global warming. There's even evidence of this in the fossil record. It's happened before. We'll talk about that later. all of this is known. This isn't like conjecture. This is all stuff that you can measure and see. And when you do the math, the negatives are pretty small and the positives are really strong. And the methane hydrate thing is like much bigger potential than all humanity combined. So in other words, there's very weak self-regulation of climate on our planet and very strong self-perpetuation of warming. So you could say that once warming gets started, it picks up steam on its own, like a snowball effect. And that turns out to be really scary bad news. We're playing with fire. Once you start this thing, it can get away from you. Don't let anybody tell you that this is no big deal. Okay.